Fundamental counting principle. So what does the fundamental counting principles? So if we can choose one item from a group of A items and another item from a group of B items, then the total number of two item choices is A times B. And we can expand this to more than one group. So if we choose one item from a group of A items and a second item from a group of B items and a third one from C items and so on, then the total number of N item choices is A times B times C, etc. It depends on how many groups do we have. Suppose you have 2 jeans and 3 shirts. How many different outfits can you form from 2 pairs of jeans and 3 shirts? So we have the 2 pair of jeans, so you can wear the first one with the 3 shirts or the second one with each of the 3 shirts. So notice this is the same as 3 times 2, so 6 possible outfits from 3 shirts and 2 jeans. So you can wear the first jeans with each of the 3 shirts or the second jeans with each of the 3 shirts. Let's add 2 pairs of shoes. So we have 3 shirts, 2 pair of jeans, and now 2 pair of shoes. So we saw the first 6 possible outfits. So we're gonna combine 1 pair of shoes with the first 6 pair of outfits. So that's 6 combinations. Now let's change the shoes to the black one, and that's another 6 outfits from 3 shirts, 2 pair of jeans, and another pair of shoes. So 6 plus 6, that's 12, or it's the same as 3 times 2 times 2, that's 12 possible outfits from 3 t-shirts, 2 jeans, and 2 shoes. Sam can take one of the 3 routes from home to town and then 4 possible routes from town to his school. If he doesn't retrace his steps or his routes, how many different possible ways can Sam walk from home to school? Now he can take this route with this one, or he can take the first route with the second one, or the first route with the third one, or the first route with the fourth one. Similarly to the second route, he can take it with each of the 4 routes we have, or the third route with each of the 4 routes we have. So 4 plus 4 plus 4, that's 12, or it's the same as 3 times 4, that's 12 possible routes from home to school. Maria has 9 different skirts, 7 different shirts, and 10 different earrings, 2 different necklaces, and 5 different shoes. Choosing one item from each category, in how many ways or in how many different ways can Maria dress up? Notice the word different here is very important. So we have 4 choices for the answers. So what is the answer? It's 6,300. And how did we, by the counting principle? It's 9 times 7 times 10 times 2 times 5, that's 6,300 ways. A new restaurant has opened and they offer lunch combos for $5. With the combo meal, you can get 1 sandwich, 1 side item, and 1 drink. Now the choices below. For the sandwiches, we have 3 choices. We have chicken salad, turkey, grilled cheese. For the side item, we have chips, french fries, and fruit cup. And for the drinks, we have soda and water. Find the total number of possible outcomes. Now we can apply the fundamental counting principle right away. But let's see what are also, let's see a tree diagram of the choices. So with the chicken sandwich, you can have chips, and also for the drink, you can have soda or water. Or with the chicken sandwich, you can have French fries. Again, for the drinks, you can have with that choice soda or water. With the chicken sandwich, you can have fruit cup, and you can have soda or water. Similarly, for the turkey, you can have chips, soda or water, or French fries, and for the drink, soda or water, and fruit cup, soda or water. Similarly, for the last choice, for the grilled cheese, therefore, we have 18 choices. That's 18 total combination. We can avoid the tree diagram by multiplying 3 times 3 times 2, and that's 18 combinations. Sarah goes to her local pizza store. She can order a medium or a large pizza with 6 different toppings and 4 types of crust. How many different pizza can Sarah order? By the counting principle, is 2 times 6 times 4, that's 48 pizza. You are taking a multiple choice test that has 10 questions, and each of the questions has 4 answers, with 1 correct answer per question. If you select one of the 4 choices for each question and leaving nothing blank, in how many ways can you answer the questions? Notice we have 10 questions, and each question has 4 choices, A, B, C, D. In how many ways can you answer the questions? Now, for question 1, we have 4 choices. For question 2, we have 4 choices. For question 3, we have 4 choices, etc. We have 10 questions with 4 choices each. Therefore, the number of different ways you can answer the questions is going to be 4 times 4 times 4 times 4, because we have only 4 choices for each question. And since we have 10 questions, that's 4 to the power 10, that's 1,048,576. Mark must choose a 5-digit PIN number. Each digit can be chosen from 0 to 9. How many different PIN numbers can Mark create? Note, in this question, repetition is allowed. So now we have a 5-digit PIN number, and we can have 0 for the first one as a PIN number. So for the first digit, we have 10 choices. For the second one, we have 10 choices, because from 0 to 9, that's 10 numbers. For the third one, we have 10 choices. For the fourth digit, we have 10 choices. And for the fifth digit, we have 10 choices. Therefore, he can create or choose from 100,000 choices to create a 5-digit PIN number. Mary must choose a 6-digit PIN number. Each digit can be chosen from 0 to 9. How many different PIN numbers can Mary create if repetition of numbers is not allowed? So for the first one, we have 10 choices. Now repetition is not allowed. So for the second one, we have 9 choices. For the third one, we have 8 choices. For the fourth one, we have 7 choices. For the fifth one, we have 6 choices. And for the sixth one, we have 5 choices. Therefore, the number of PIN numbers she can choose is 151,200. Telephone numbers in United States begin with the 3-digit area codes followed by 7-digit local telephone numbers. Area codes and local numbers cannot begin with 0 or 1. How many different telephone numbers are possible? So keep in mind, the area code and the local cannot begin with 0 or 1. So the telephone numbers for the area code, they cannot start with 0 or 1. So for the first digit, we have 8 choices. Then for the second digit, we have 10 choices. And for the third digit, we have 10 choices. Now the local number is 7 digits. The first one cannot begin with 0 or 1. So for the first digit, we have 8 choices. And then the rest is 10. Then the total different telephone numbers that are possible, we multiply all the numbers we have, and that's 6,400,000,000.